thank you all who have produced this conference and all your work going into it. I'm Robert Schwenker. Thank you all for being here today. We'll go over some of the basics of blockchain, some of the terminology, and look at the ecosystem a little bit. I've been doing work with financial technologies for some time. I was at PayPal when I realized, the programmable money was a very big deal. And people at PayPal thought it was a big deal, but they were a little worried about my activities at PayPal, promoting sort of blockchain courses and meetups and such, because Carl Icahn was trying to split eBay from PayPal, which he later did. But they were just a little worried that they get an article in the New York Times, PayPal is doing Bitcoin because Schwenker's teaching blockchain classes in the basement. So we were doing classes at Boost VC, interestingly, in San Mateo. And that sort of became the birth of what later was Blockchain University, which I created with some other founders of blockchain startups and such. And from there, I forked out and created DLT Education to educate people on blockchain technologies. I've recently done some work with the United Nations Women Agency. We're looking for cash transfer and identity solutions for women refugees. So with that, let me just go to what we'll try to cover. Some of the terminology, we'll look at distributed ledger technology as a term, and blockchains, and a little bit on smart contracts. And then we'll look more a bit at what are ICOs and some bits about the ecosystem in ICOs. If there are questions throughout, I'll take several questions along the way if you have one. So from here, we will look at Satoshi Nakamoto's white paper. If you've not read it, this is your homework. You really should have a sense for what is the white paper, what he was trying to set out to do, when he set out to do it. It was in January 3rd, 2009 that the first Bitcoin machines or nodes came up and started mining Bitcoin and all. And this was kind of a fundamental revolution. It was done for the purposes of me being able to provide you with money over the internet without a third party. So a lot of people who are in the sort of crypto anarchist movement got involved in this at this time, and it became significant. As Milton Friedman was predicting kind of internet money back in 1999, and it was Satoshi who really cracked the nut on this. There were many other attempts to do that, Hashcash, DigiCash, and so it was Milton Friedman predicting this, and then Dan Moorhead from Pantera Capital created this diagram to kind of illustrate the importance of a money protocol for the internet. We all have gotten used to use protocols on the internet really without even knowing, but we figured out what to do is type in HTTP and HTTPS and such. But what is the money protocol of the internet? How do we send microtransactions and macrotransactions and such more efficiently the traditional banking system? Interesting, a lot of this activity that occurred has made traditional banking systems a lot faster. Has anybody sent a SWIFT payment recently? If you have, you'll notice it's gone much faster than it had previously. So it's really created a lot of inspiration in the ecosystem to improve current financial systems and create a lot of new innovation in the ecosystem as well. So at the heart of it, I think we could say Bitcoin is kind of one form of programmable money, and there are literally thousands of programmable monies now, and each of these represents a blockchain. So this is a site, CoinMarketCap. If you've not been there, certainly you can visit that and look at really the kind of ecosystem as a whole, particularly from the cryptocurrency perspective, the list of publicly listed cryptocurrencies, and their so-called market caps. If you've been following this across the month, you'll see these wide swings. And in December of last year, the coin market cap was so-called $850 billion. And today it's around $200 billion. So massive fluctuations in this ecosystem, very interesting times that we're in. So when people say, what is the blockchain, it really makes me think, what are they talking about? We do know what we say when we say the internet, we kind of get that. But is there a blockchain that is the blockchain? I think there's been a lot of inspiration to kind of think about a single blockchain technology as the blockchain. And we hear that a lot, I think, from certain groups of people. I think Ethereum has done an amazing job in sort of creating this ecosystem and building it out, and Ethereum is kind of an advanced Bitcoin type of application platform as such. But we often hear that it's the blockchain that's going to solve X, Y, Z. But there's many blockchains, as we saw on the previous slide. So each one of those cryptocurrencies is typically on their own blockchain or related to another blockchain. So this is just for your entertainment. It's from my neighborhood. What is a blockchain? So if we look at Wikipedia, we can learn about sort of the growing list of records. And these records are secured through cryptography, okay? And these records are in the form of a block. So there's inside of a block a group of transactions typically that represent transactions of value, me sending you a Bitcoin or a portion of a Bitcoin, or to many people a number of Bitcoins as such. And so each block, inside of each block, there's a timestamp for when this block was created. There's all the transactions that have gone on that we can typically see. And there's a link to the previous block. So in computer science, we call this like a reverse linked list. Each block is linked to the previous block until there was an initial block called the Genesis block, and that's what happened in January 3rd, 2009 for Bitcoin. We had our Genesis block, and from there, the Bitcoin blockchain has grown, okay? Something to keep in mind that there's this idea of forking, and there's a number of possibilities for blockchains to fork and such. But as such, today the Bitcoin blockchain has become the sort of dominant blockchain that's at least in terms of its cryptocurrency coin market cap value. But all blockchains typically have this as characteristics for them. Blockchain data is inherently resistant to modification. Another analogy we may use to think about blockchain technology is like a shared Google Sheet. And in that shared Google Sheet, it's an append only, so we can only append new rows to that Google Sheet. In fact, each of us, if we're running the Bitcoin software, and we are each so-called miners in this ecosystem, only one of us can add a new row to that Google Sheet. And in that row has the transactions for that period of time in which that block was created. We can extend that analogy to the competition that happens that we call mining. So each of the nodes or computers on the network are mining, they're competing to create that new row. And when whoever wins the prize gets an award. And today it's 12.5 Bitcoins. But imagine we were all playing the same Sudoku game. And I would say whoever finishes the Sudoku puzzle first, and it's the same puzzle for everybody, I'll give you $1,000. So we would all rush to figure out that particular problem, that particular Sudoku problem. And if you created that, if you finished the Sudoku puzzle and were given the award, then you would create that new record, that new row in the blockchain, in the Bitcoin blockchain or whatever blockchain you're mining. This is a typical drawing that is given for a series of blocks. There was block number 0 or block number 1, and these are the blocks linking to each other. There's a previous hash, which is the link to the previous block. There's the timestamp, and within the transaction root, you'll have the number of transactions that occur for that given block. Okay? This won't be on the test, but do take note. So we hear a lot about blockchains as well as distributed ledgers. Blockchains are a subset of distributed ledger technology. When one says DLT, one could also think about decentralized ledger technology. And there is a difference, but distributed ledger technology is typically applied to more permission types of ledgers where you need permission to write transactions to that ledger as such. Maybe even permission to read transactions in that ledger. So we've had many types of ledgers through time, and finally we're getting ledgers that work on the internet with big groups of people. And what these distributed ledgers are like a type of a database where there's a kind of a consensus about new data that's added to that ledger. And this ledger is synchronized across the network. And this network might be across institutions, banking institutions, or governments, and or geographies. So Bitcoin is an example of a distributed ledger. Ethereum is an example of a distributed ledger. Okay, those are public ledgers. And we hear a lot about distributed ledger technologies. We can also compare distributed ledgers to distributed databases. So a distributed database requires permission. And it's also typically has some kind of centralization characteristic. Could be the software itself is controlled by either a single vendor or a single party. The permissions for that, the key management, the permissions to enter in that particular network, that distributed database network, or typically have some aspect of centralization. In contrast, with distributed ledgers, there may be copies of ledgers that are secured by each of the individual organizations participating in this network, and those are in essence secured by each individual organization as opposed to centrally. So the ledger data itself is replicated around. The ledger technology itself is distributed and a part of each of the organizations. However, how those organizations maintain that data and such is not centralized. It's per the individual organization's management of that ledger. So let's move on to distributed ledgers themselves. As I said, blockchains are one form of that. There's also transaction chains. So we can imagine adding on a single transaction rather than grouping transactions into a block. If you think about identity systems on blockchains, it's curious to note, how do you deal with things like the right to be forgotten if you're writing identity data into a blockchain? There's a lot within that one could abstract, but I think this is whether blockchain technology is useful for identity or not is perhaps a separate question, separate discussion. But would you want your identity data grouped together with lots of other persons inside of a block as such? So one could imagine an identity system perhaps formed with a transaction chain, where it's a single transaction that's appended to a chain. And maybe identity data is useful in that context. Of course, data is typically hashed and such. There's other considerations there, but just as an example to talk about a transaction chain. The most popular transaction chains that we're hearing about today are called DAGs, or distributed acyclic graphs, directed acyclic graphs. And these types of data structures store the transactions in nodes, and each node typically will hold a single transaction. Later today, we'll be hearing from a colleague from Hedera Hashgraph. And so that's an example of a DAG, Hedera Hashgraph. You might have also heard of IOTA as such. So those are examples of technologies which we call DAGs, or transaction chains. So let's move on to the term token. So how many of you, by the way, own any cryptographic tokens? If you're okay, great. So what is it that you actually own, and where do those tokens sit? Are those tokens on your phone? Maybe. Are those tokens on the nodes of the network? What is it that you hold? Do you hold the cryptographic keys that allow you access to those tokens and allow you to send them to somebody else? So if we're talking about any digital asset, whether it's an Ether token or a Bitcoin token or a utility token, the tokens themselves typically reside on the various blockchains. You may have a copy of the blockchain or a simplified version of a blockchain on your phone or your laptop. But these are examples of cryptographic tokens. When we talk about utility tokens, we're talking about tokens that don't typically themselves have a value. They're tokens that are used for storage and compute, and I'll give examples of these later in the talk, or companies that are doing that for digital advertising as well. When we talk about the ERC20 token, what is the term that we generally think about for ERC20 token? Scam. Oh, okay. What else? Okay, well, I'll give you. Starts with a letter I. ICO. Okay. So the ERC20 token tracker tracks typically tokens that were created using the ERC20 token standard to create typically an ICO, or initial coin offering. My clicker is very happy today. So non-fungible tokens. What are non-fungible tokens? These are what we might put into the sort of utility token category. Tokens that don't have fungibility. A Bitcoin is a fungible token. If I send you the Bitcoin that I bought yesterday or the Bitcoin that I bought 3 weeks ago, it's essentially the same Bitcoin with the exact same value. But if I have a token that represents this chair, or the land on which this building sits, that's a unique token. And the token that would represent this chair wouldn't be something that I could use to go purchase another chair as such, or a cup of coffee, or put it towards purchasing a piece of land. It's a non-fungible token. It's a unique token. It's a token that represents an asset that typically has some unique characteristic to it, is what we generally talk about when we say non-fungible tokens, representing something unique. It's not interchangeable. And the ERC 721 standard is really the closest that we have to a standard for representing these non-fungible tokens. So there's a lot of interest in this sort of area as a new trend in this blockchain technology ecosystem. So examples of this are probably the most popular example is of CryptoKitties. The CryptoKitties where you can buy a unique CryptoKitty. If you play the CryptoKitty game, you're engaging with ERC 721 tokens. And where is my cat picture here? This is the ability to buy a unique. Anybody own any CryptoKitties? Okay. Have fun, go out and buy a CryptoKitty and experience an ERC 721 token. But essentially, they're unique. Each is unique. I heard one was sold for $140,000 at a charity, believe it or not. A very unique CryptoKitty. So when you play the game, you can get a couple of CryptoKitties and you can mate them. And what happens is a new ERC21 token is created with the baby from the mate. And so you have two unique ERC 721 tokens with genes and DNA and such, and they go to create a new ERC 21 token that represents the new digital cat. And then you can sell that cat on the CryptoKitties marketplace. Cool, right? Those guys got 12 million in investment, such. Interesting. So one other diagram here, I'm sorry. This, the non-fungible token ecosystem is here, and we talk about sort of the apps that are there, the publishers of these apps, the marketplaces, the infrastructure, sort of resources involved in there. Under infrastructure, you might have heard of the MetaMask wallet. Anybody have a MetaMask wallet? Probably about a third of you, I'm estimating, or okay. So MetaMask is a way that you can create a wallet inside of a browser and exchange cryptocurrency, typically Ethereum, right? Initially Ethereum and other coins as such. But MetaMask is what you can use to buy and as your wallet to buy and sell CryptoKitties. There's marketplaces for CryptoKitties, such as Rarebits. It's kind of like an eBay for digital assets, for non-fungible token types of assets. People are selling these other types of assets on OpenBazaar. If you've heard of OpenBazaar, it's kind of like a distributed, decentralized eBay. Kind of like maybe sort of like an a decentralized Silk Road to some extent. One could associate it with that, but I think they're really steering clear of a lot of the challenges that happened with Silk Road. But OpenBazaar, I think, is one of the most interesting projects in the space, personally, from this collection of DAP Radar and others there are tracking the various sort of publishers and stuff of various apps and such. So let's move on to the term smart contracts. And smart contracts, are they smart? Are they really contracts? From a legal perspective, we could talk very specifically about a smart contract being an automated and an enforceable agreement. This is what sort of, from the legal perspective, the attempt to do. If we think about originally in the Ethereum ecosystem, smart contracts are a way of providing computation on a blockchain. So by creating a smart contract, you're creating a program which has its own wallet, and a person can send funds to the wallet to initiate that program to transfer value out of it. In the sort of more formal, in sort of the distributed ledger technologies in the more permissioned world, there's been efforts now to marry sort of legal code with computer code. This is sort of the cornucopic vision, as it were, for apps that run inside of distributed ledgers that provide a form of agreement which is enforceable. So automatable by computer through some parts may require human input. For instance, if there's a disagreement with a contract, you may have human interaction. So this interaction requiring humans may require enforcement agencies, legal agencies and such. But ideally, a contract is written so it lessens or eliminates the need for human involvement. So Bitcoin has its own smart contracts. Bitcoin has a multi-signature contract, so that it might be many of us or several of us, say, that are required to sign a transaction before value is transferred, a multi-signature transaction. Bitcoin also provides for a time-locked transaction. I'll send you $1,000 of Bitcoin on your birthday, and it gets unlocked. Or we can combine the two. We will send $10,000 to each of our core investors if 3 of 5 of us sign off on the transaction, for instance. There's a lot of work to creating more complexity in smart contracts, and there's a number of companies that are working on that, particularly for the Bitcoin network itself. Ethereum, when it launched, really had its own smart contracting platform. That was inherent to it. And so one may think of Ethereum as kind of a Bitcoin 2.0, if you will. Bitcoin one can think of as kind of like an abacus, where we have account balances that we exchange on the ecosystem. But we may think of Bitcoin, as Vitalik Buterin, its core founder, talks about it as a global computer. So it has characteristics of decentralized storage and decentralized compute power. And it's like, and the ability to run these smart contracts or programs. Each of these smart contracts has a wallet, and it provides for the functionality of decentralized program capabilities. The R3 consortium has created something they've called Corda contracts with stateless verification functions. Unlike Ethereum functions, which are stateful, essentially the Corda, or Cordaps as you were, provide sort of a stateless verification function. So it may be that on a Corda network, a transaction is validated, and once it's considered valid, it gets written to the so-called Corda ledger, if you will, which typically is a ledger that represents data that's shared by a certain subset of parties within the whole Corda domain, if you will. Accord is a project that is now starting to get incubated under the Hyperledger organization. The Hyperledger organization or hyperledger project, as Brian Bellendorf often refers to, that has many projects like animals in a barn, as he says. Accord will soon be one of them, we think. It's in incubation now as such, but Accord provides a very formal kind of way of defining smart contracts and relating the computer code to the legal code. So techno-legal standards and open source software tools for smart contracting. So they have sort of a foundation of experts, of legal and technology experts with their open source software. They have a number of templates for different types of legal contracts and agreements. And it's a Accord project, I think, is a very good way to sort of learn about the basics of the sort of legally enforceable types of smart contracts. And they're trying to create standards around this as such. So Accord project provides for smart contracting templating, if you will. Corda as well, within the Corda open source framework. And these are projects that are more related to the distributed ledger technologies within permission networks. So we have a quick discussion about an ICO. We'll save the jokes for later and Dilbert and all. But essentially an ICO is a token sale or a crowd sale. There's also, well, I think we'll start to see more of the initial security offers that look more like sort of stock offerings as such. What is an ICO, or initial coin offering, or a token sale? It's kind of like a Kickstarter. There's a whole, typically there's a team behind a white paper and hopefully some kind of code. There typically is like some kind of sale announcement. In Ethereum, as we said, commonly uses the ERC20 token standard. There may be a foundation for the governance, which may consist of the team, various users perhaps, investors, and a foundation, and there's a marketing and launch. And an example of an ICO, this is one that was done by Civic, gives a token sale terms and such. It turns out Dilbert's founder, Scott Adams, is doing an ICO right now called WinHub, sort of for experts and such. And WinHub is now worth $250 million. I think he's trying to raise some $10 million or so. And it's ending next month. So I wasn't paid to promote that, but anyway, I thought you'd be interested. Golem provides for compute resources on the Golem network. So the idea is that your laptop at night can be opened up, and instead of Airbnb, your laptop can sort of have an Airbnb experience where you're sharing out its compute resources, its graphical chip and CPU chip resources. And what do you get paid in? Golem token. So these guys raised $8 million in a half hour, like crazy, right? Sean Wilkinson did 2 ICOs. He has sort of a decentralized storage like Amazon EC2. He did his first launch, which happened before Ethereum, and his second one is at 2017 around the Consensus Conference in New York. He was there telling me, he was watching his phone and the money funnel, and he raised close to 30 million in total. This is one of the most interesting projects in the space, the basic attention token, Brendan Eich, who created Firefox and JavaScript in 10 days, raised $35 million in just less than a minute. So that was very interesting and kind of revolutionary as such. Unfortunately, only a few people bought into his ICO. Everybody had their finger on the enter button to sort of invest, and someone paid, what, a $6,000 miner fee in order to get their transaction through to buy some millions of BAT token. Very interesting, disruptive. If you download the Brave browser, you can get some free BAT token, by the way, if you look under their configuration settings. Civic did a very interesting thing. He had everybody download his app, and he essentially had their real phone number before he would identify them and allow them to buy between 50,000 and I think 5 million. He had some very interesting lawyering going on because he said that he called this this token sale is basically selling software licenses. So when he received the money, he paid tax on it. So in case the SEC went after him, he could say, well, if I need to pay an SEC fine, I'm going to have to get a refund from the IRS first before I pay the SEC a fine. Anyway, it was an interesting kind of maneuver to raise money as selling of software licenses. Numerai, interestingly, was like BAT, a startup that had revenue, that had investment and such. And he didn't really do an ICO as such, but he gave away millions of tokens to 12,000 data scientists. And basically, those data scientists kind of play a game where they create a data model based upon a data set and stake some tokens. And if their data model beats the market, they get rewarded. If they don't beat the market, their stake of coin gets burned or eliminated as such, or sent to as such, burned. This is Juan Benet. He was one of our early speakers at Blockchain University. I think one of the persons with the most integrity in the space. He created IPFS, the Interplanetary File System. He created CoinList with Ravel Navikant and AngelList and such. He did a Filecoin IPO. It was one of the biggest at the time, $250 million. And someone else to follow, I think, as well as accredited investors can invest in ICOs or as such on CoinList. This is Olaf Carlson Wee. He was the first hired person at Coinbase, but he went off to create Polychain, and he's very excited about the space and talks about crypto protocols to result in trillions of dollars of values in the next decade or so. You can take a look at a number of these sort of ICO offerings on Token Market. Very interesting. And our last slide here is this a dire situation where so many of our ICOs have been sort of going from a very high point to loss of some value. But this is sort of a level setting. I think we've seen a kind of a correction happening in the marketplace. And we saw that sort of in the dot-com bubble. Whether we're bottom of that correction or not, I'm not sure. But something to consider. So for now, we talked about DLTs and fungible and non-fungible tokens, smart contracts who keep getting smarter, and ICOs. So I'll turn it over to Brett.
Any questions from the audience?
In terms of really benefit for the users, what's the, I guess less from a technological perspective, more for benefit from a users, how these two technology differ?
The two technologies are DLTs versus blockchains, or versus, say,
hash graph, yeah,
yep.
Versus blockchain.
Yeah. So essentially, we're using cryptography to secure data. And it's in the form of a data structure. And blockchain technology itself typically groups transactions into blocks. DAGs typically group they don't group transactions. They have single transactions that are confirmed by each node, and those nodes speak with each other. There will be a presentation by Hedera Hashgraph that will get into more depth than that.
Okay. So is that quicker, cheaper, better, or less? I don't know what's the difference.
It's a different data model. It's a different data structure and such. Typically, one could say that those transactions clear much faster and would lend themselves to things like Internet of Things types of technologies, DAGs, as it were. In the IOTA case, they don't have transaction fees. So in a sense, it's cheaper, it's free, but it's based upon the miners themselves who agree that they want to support that network. So the costs are taken elsewhere in the ecosystem as such. I hope that sheds some light on your question.
Yeah.
Happy to talk about it offline. Yeah.
Thanks.
Just take another question in the front row here. I can probably hear you. Yeah, I'll repeat the question.
On the current state of ICO, I see that the prices of all these tokens have fallen dramatically in value. Can you comment on the current environment, why that is happening, and do you see the ICO being more popular or less popular in the future? What's your prediction?
Thank you. My prediction about the ICO market in a certain condition, I think we're obviously seeing a correction. I think there's been massive amount of fraud in this space, unfortunately, and I think a lot of that will be regulated away. I think the ICO form of raising money will continue to evolve. I think in the US, many people are using mechanisms that involve just accredited investors, in some cases also doing sort of crowd investing outside of the US in combination. Many people are just staying clear of the US. I think the ICO market will, particularly in the US and other jurisdictions, get more firmly regulated. And the number of central banks, number of governments are focusing on creating ICO regulations, such as Japan, Singapore, Switzerland, Malta, and some will be looser, some will be more strict, South Korea also. My prediction that it will continue to disrupt traditional venture capital, and they'll be sort of emerging with sort of traditional VC investment, as well as sort of this new ICO or investment using tokens and such. Thank you for your question. Take one more question.
So the question I have is around the ICO market as well. I'm not going to ask what you would predict to be the first real world application, because that's an arguable point that a lot of people are discussing right now. But which one would you predict would have the first mainstream adoption outside of arguably Bitcoin and Ethereum, arguably?
Like I showed, I think BAT has a chance. The Basic Attention Token, Unbank.Ventures Filecoin, I think. I don't put a lot of time on predicting sort of the best sort of applications, in other words, so I don't do, I think though, those that, there'll likely be a consumer type of application. Mm-hmm. And I think those still are my favorites, the Filecoin and the BAT token. But whether they'll be first out and real scalable, as Vitalik Buterin says in this ecosystem, there'll be many, many sort of winners coming up.
So I think building out a comment that Tim Swanson, who will speak on one of our panels later today, said, he said, the only reason people come to these conferences is to get token recommendations. So I think there's like a legal disclaimer. We are not, we're not a broker dealer. We're not, So I mean, a lot of this stuff gets into security stuff. Robert's a great expert on the underlying technology, and I totally understand why you're asking these questions. But with that said, any final comments before I let you go?
I'm not an investor in either of those, so I think one lady had a question.
Any final questions? Yes, no? Going once, going twice? Okay, big round of applause for Robert.
Thank you.
Thank you. Sir, absolute pleasure.